Which of the following gives a single solution of the inequality the absolute value of x plus 3 minus 2 is less than or equal to 0, and shows a graph that can be used to determine the entire solution set of the inequality? All right, so in order for us to solve this type of problem, we don't necessarily need to evaluate anything. We just basically need to know how to set up the graph for an inequality like so, and decipher or be able to pick out what are the solutions as when those two functions cross. So let's go ahead and get started. So in order for us to think about what my absolute value of x plus 3 looks like on the graph, I can refer back to the standard form. So we're the standard form of an equation, which is a little bit different than an inequality. The equation standard form is written as f of x is equal to the a times the absolute value of x minus h plus k. So where I can find out what my vertex is by taking these two values here as h comma k. Now I know we have an inequality, and when I'm working with graphing such inequalities, what I have to do is first put this into a standard form of inequality by moving this value of 2 over. So if I have f, or absolute value, of x plus 3 minus 2, which is less than or equal to 0, in order for me to figure out what this would look like on the graph, the first thing I want to do is add 2 on both sides, so I'm just left with my absolute value on one side of the equation. Okay, so now this is set up to something where it looks like I can graph the two different values. Now, looking here, it somewhat follows a little bit of this form to where I see that I've got my h value and a missing k value now that I moved that 2 over. So therefore, seeing as though this is a positive and my standard form is typically written in the negative, that means that the value of h has to be a negative for this to turn into a positive, right? If I were to stick in negative 3 into here, it'd be x minus negative 3, which gives me that plus 3. So therefore, my h value equals negative 3, and my k is equal to 0. So my vertex, write that here, vertex, I'll show that up here as well. This is standard form. Is going to be negative 3, comma 0. So then looking at the graph options, I can already go ahead and cancel out this graph and this graph because I see here that I have vertex values at 3, positive 3, 0, positive 3, 0. So now I just need to kind of look and see what would be my solution sets here. So for the first graph, they went ahead and graphed the absolute value of x plus 3. And then for the straight line here, that's where my the solution, the proposed solution to my absolute value comes in. So I make a second line, which I will call y2, and that equals 2. And that gives me that horizontal line that I can use to cross-examine my solutions. So when I look here and I see my solution sets or my solutions when y is equal to 2, I see that I have values x equaling 1 and x equaling negative 5. Here, this one tries to tell me that I have a solution here when x is 0. And I could see that I have two different things going on when x is 0, so that can't be it. Let's take a look at this one. Here again, I still have solutions at negative 1 and negative 5. And look at that, x is equal to negative 1. That is what we are talking about.